What's up, YouTubers? So today we're going to put the skills that you learned in the previous video on how to use voltage testers and amp meters and all of that. We're going to put that to an actual useful test, and we're going to calculate out a rough efficiency on this unit. So in order to do that, we need to know what our starting voltage is that's feeding into this machine, and we need to know how much amperage this machine is actually pulling under load. So in a previous video where I tested this unit, I found that the amp setting of 90 amps on it is actually pretty accurate to the output of 90 amps. So we're going to put it on that, and we're going to run a bunch of short, like probably 1 or 2 inch welds at 90 amps. And we're going to watch the voltage here that's coming out of the wall, which it should stay pretty close to 119 volts that it is right now. And we're going to monitor the amperage draw of the machine. Now, this machine actually outputted 130 amps on a 20 amp circuit, which I truly believe is probably well over 20 amps, to the point that it'd probably trip a breaker. So I'm hoping 90 amps is closer to like 15, 16, but we won't know until we test it, right? A couple things worth noting here. One, this unit that I'm going to use to split the wires to where I can clamp amp meter it out is only rated for 15 amps. So if this gets too high, it could potentially melt the wires in here. Now, this is obviously set up pretty safe. I mean, it's encased in plastic, so worst case is I smoke it. I don't want to do that because why waste it then? But I'm hoping that a few short welds won't cause an issue there. And second off, you know, I got the probes just sitting in here, but again, I'm not putting my hands anywhere near any live wires or anything. You want to be smart about this, like you're not playing with 9-volt batteries here. So I'm going to reposition the camera to where you can watch both the voltage and the amperage that this machine is operating on while I'm welding. And you'll just have to listen to the arc start and then cut out and start. I'll do like 4 or 5 tests to get a baseline average of amperage at what voltage. So right now it's set to AC, and just the machine idling is drawing half an amp. So pretty low, I guess. I mean, half an amp is a lot, but I mean, there's a fan running on it. All right, I have no idea what the results of that were because it doesn't save it. I could have set it up maybe to hold it, but I have no idea right now. So what I'm going to do now, based on that evidence, I'm going to now take and clamp these meters on the output side of this. Sorry about that getting in front of the camera. I'm going to clamp the meters on the output side of this welder, and we're going to look at what the output amperage is and what voltage. All right, so now we're set up for DC amperage on the output of the welder, and this is the output voltage, which is DC voltage. This is open circuit voltage. We'll see what the running operating voltage is once I strike an arc, but we want to see where this is. This should read somewhere around 90 amps. My guess is probably 22 volts. We'll see though. All right, I have no idea what the results were, but I'm going to review the footage and then come back and we'll talk about what the findings are. All right, so this red Amazon special welder, we got the inputs and the outputs. I apologize, in the video it was a little bit difficult to see some of the amp readings on the input. The average were these. This was the average voltage at the wall. The reason this is dropping is the current pull through that wire, which is 12 gauge wire, and it's on a 20 amp circuit. Well, the current was so high that voltage loss through that conductor size 12 gauge likely played a role. Had it been a bigger wire, there would have been less voltage drop. So anyways, the average was 28.6 amps at 112.4 volts for input. In case you're wondering why 28 amps wouldn't trip a 20 amp breaker, well, most breakers have like a thermal trip on them, and then they have like a dead short trip. At 28 amps, over time, a little wire or mechanism would heat up in the breaker and then it would trip it. So likely this welder, if I welded for like a minute or two, it would trip the breaker at 90 amp setting because it would trip the thermal. Now from a dead short, it would have to probably be, I don't know, 35, 40 amps instantaneously or higher in order to trip it. So this would be kind of like a delay trip on this. Now for output, as in my previous video where we checked it, it's pretty much dead on and only at 90 amps output. Every other setting, who knows where it's at, but 90 amps, so pretty accurate, which is good. Voltage was a little bit less than I thought it was going to be. I would have thought 22, 23. I mean, it sort of got there, but 21.5. So our average output was 90.4 amps and at 21.7 average voltage. Very simple stuff. Now, we're also going to do one more very simple calculation, and that's we're going to see how many watts was used on the input. And to calculate watts, we just take the average amperage and by the average voltage, and that gives us our average wattage, which is 3,214, which is actually, I would say, pretty high for a 90 amp output. Now, average output, to calculate watts, we take 90.4 times 21.7 volts. That gives us an actual wattage output of 1,961. Then we take that and divide it by the 3,214, and that gives us a 61% efficiency. Now this is a very rough number. You would have to get a closer number, you'd really have to do a lot more calculations, and the way I metered everything is not really gonna give a complete accurate picture. And I'll spare the details on that because really it doesn't matter. I mean, we're not building electronics here, so it's not an issue. So anyways, 61%, that's low. I don't know if it's really lower than I expected it to be or higher. I mean, it is what it is. It's 61%. I thought I wasn't going to do it mainly because I didn't have an adapter, but why don't we test the Dynasty that I have and just see what that efficiency is. Now, I don't have a 110 outlet cord for it. It will run on lower voltage. So I'm going to have to do something, I don't know, I'll rig it up somehow to the outlet and we'll do the same tests on it, and who knows what we're going to find. All right, so now I'm going to test the Miller Dynasty 210. The right's depicting wall outlet voltage, and then the left guy here is on AC, I think it's on AC amperage. Nope, it was on DC amperage. Let's switch it. So we're on AC amperage. This unit on 120 volts is rated to pull, I think, 28 amps to output 90 amps. So the machine's set to 90 amps. Same as the other welder. Let's run a couple passes. All right, now I'm going to switch the meters over to the machine and then we'll take a look at what it's actually outputting. All right, so this on the left shows output open circuit voltage, and then on the right it shows output amperage. The machine is still set at the same 90 amps. No settings have changed. So we're going to see what the operating voltage is, which should be actually the same as the other red welder, the Amazon Special, and then our output amperage, which should be right around 90 amps. All right, I have no idea what the results are. Gonna watch the video and then come back and we'll talk about the findings. Well, we got some interesting results here. So the Dynasty did 3 tests, same as the other welder, it's the Amazon Special. Our amp draw average was 24.8 and our average voltage was 112.2 for what it was pulling. Now, if we go back to this, you can see our amp draw from the wall hugely lower. So about 4 amps lower overall, so that's a good thing. Now the output at a 90 amp setting was between, you might as well say 94 amps. I mean, pretty much, average 93.8, all of these are just rounded guesses. Voltage of output was slightly lower. So 20.8, so about 1 volt lower, couple amps higher. I have an idea of the reason behind this. Now, when I set the welder to 90 amps, the arc force controller dig setting on the machine was set at 30%. And that doesn't relate to like 30% more amperage. It's just a percentage, kind of like 1 to 10, how much do you want? Well, I believe what it was doing is at the standard 7018 setting of 30%, it was slightly boosting the amperage up when I was running a tight arc, and I always run a tight arc, so it slightly boosted the amperage over my initial setting. Had I set that to 0 for arc force, I believe it would have been dead on accurate instead of a little bit higher. Now the voltage is less, which is interesting to me. I think what maybe have been going on is I was able to hold a slightly tighter arc with the rod because the amperage was slightly higher. Because the voltage shouldn't really vary that much because they both outputted approximately 90 amps, a little bit higher here. But the voltage is dictated by your arc gap. So the only way to have less voltage on a normal, like while you're running the rod, is essentially to have a tighter arc gap. Like there's no other way around it. So my guess is I was holding a slightly tighter arc gap because the amperage was slightly higher. And I'll show you why, at least mathematically in this testing, why that works out. And we'll go to the next page. So I'll move this over here. So again, we take our amp and volts and we times them by each other, and that gives us 2,782.56 watts. So significantly lower wall outlet power, which is good. Now at 90 amps output, this was drawing, about, let's see here, 24.8 amps. That probably would not trip right here. That would probably not trip the thermal fuse in the breaker. It would take a while for it. It may, but definitely a lot harder. So anyways, much less input wattage requirement. Now the interesting thing is the output being a little bit higher amperage, a little bit lower voltage, output was 1,951.04. Now the interesting thing here, it's almost identical despite having higher amperage, lower voltage. And that's simply because this, if you look at it as heat output, they both were practically identical. It's just the heat to burn the rod in this case was coming from increased amperage, lower voltage. In this case, the heat was coming from the slightly higher voltage and less amperage. Now the efficiency, right off the bat, 70%, so significantly higher efficiency. Most of this is probably simply due to what's called power factor correction. My guess is the Dynasty has it, and in very simple terms, it uses capacitors generally to, I guess a simplistic way would be to keep the voltage on the input artificially high. And that's really not an exact scientific explanation, but it just reduces the effect that reduced voltage has on the efficiency of it, and that's likely why. Now, both of these machines run on 220, which I'm not going to test that. I mean, I would have to pull the wires out of the wall to clamp to amp meter them, and I just don't feel like doing that. It'd be a pain. I have a feeling both of these efficiency, especially this guy, would go up significantly with higher voltage. I'm not positive, but it's a theory. I would assume this likely would as well. I mean, the mere fact that this welder can run on, lower voltage, 110, 120, I think is really just, I don't know, not many people are going to set it up to weld on low voltage like that. So the fact it runs it at all is awesome, because I know that the bigger Dynasties, the 280 and the newer 300, none of those can run on, wall outlet power. So I guess, considering this can, that's better than I would have expected, I think. I don't know that it's necessarily the highest that you could get. I have a feeling that there's some other welders that are designed around 110 that could probably approach a higher number than this, maybe 75 to 80. I'm not really sure. I never tested any of the other welders that I've had, and I've had a lot of them. So anyways, I guess that kind of shows a lot of the details, some similarities, but obviously you're losing efficiency with the red welder. And let's be honest, did we really think that it was going to compare to a higher end welder? Not really. And that's not meant, I'm not crapping on the rainbow of this. I'm just, we're having fun calculating stuff out with the voltage and amp clamps. So, well, let's go and I guess wrap this video up. So what did we learn today? Well, I learned a bunch of things. I learned that the efficiency of this little guy, actually, I mean, I'll be honest, it isn't as bad as I thought it would be, but it's still, pretty low. I have a feeling on both of these, like I said earlier in the video, the efficiency on higher voltage is probably a lot higher. I'm not going to test that though. But yeah, this guy is definitely a lot harder to strike an arc with a 7018 than the Dynasty is, but this isn't meant to be really a comparison between the two other than, just interesting things. And it's really more of an experiment to get you guys comfortable actually testing stuff and learning about how things work. Now, I didn't show you how I hooked this up to the outlet over there. I did hook it up through that Harbor Freight meter where it splits the wire, but trust me, I would have given the NEC code book a heart attack on the electrical wiring for it, so I didn't actually show that. But needless to say, it did work. We did get some results, interesting results at that. But yeah, I had a lot of fun making this. If you got any comments, questions, thoughts, feel free to share them down in the comment box. I like reading this stuff. So I guess that's all I got for you in this video. Until next time.